This screencast video is going to show you how easy it is to create confidence intervals for population means using Desmos. You click the Open Graphing Calculator button here once you're in Desmos, and you, just like we did with the confidence intervals for population proportions, you just push the plus button and get to the inference tool. And our first example was to get a good estimate of the average length of metal screws that are produced by some manufacturing company. So, because we're not sure if the original data set is normal or not and the size of the sample, we are going to use the t-test. So you click t-test here, and the statistics that we know was from a sample of 30 metal screws. The average length of them was 4.8 centimeters with a standard deviation of 0.4 centimeters. So you click create test, and the confidence interval, which was supposed to be a 95% confidence interval, which means you don't have to modify this box. And you can see that the lower and upper limits of that confidence interval are pretty much exactly the same as the one in the worksheet, 4.65 and 4.95. The next confidence interval we'll construct is data-based. So I have the data from my spreadsheet. These were sensory ratings after I think some acupuncture was performed on some chiropractic customers, patients. So I'm going to copy that data. And I'm going to go back to Desmos, and since these were sensory data, I'll label this list S equals. It's on the clipboard, so if I paste it, those are all those 15 sensory data values. Now I'll click in the box below and click on plus in the inference tool to perform a t-test on this data. So I will not go to stats and put all the summary statistics. I'll keep it to the default of data. I just refer to that list by what I labeled it to be, which was capital S. I click create test and confidence interval. And this is supposed to be a 98% confidence interval. So we will have to change the default of 95%. But you can see these lower and upper limits are also incredibly close to the ones on the worksheet. Moving on to the next example, which is fairly rare, where somehow sigma is known, but you don't know the population mean. Somehow you know the population standard deviation, but not the population mean. But if you do, you would use the z distribution, not the t distribution. So I'm going to click on the plus button in inference, but this time I'll select z-test, not t-test. And I do have statistics from a sample. And there were 15 babies that were weighed, and we were curious about the birth weights of females, knowing that for the standard deviation of the population it's 2.9 hectograms, but for this sample of 15 babies, the average weight of those 15 girls was 30.9 hectograms. We create the test, click confidence interval, and this is supposed to be a 90% confidence interval. So again, we'll have to modify the default of 95% to 0.90. These are incredibly close, again, to the lower and upper limits from the worksheet. Our next example, which I think was at the end of the packet, which were the problems you were to work on that I had provided a key for. Our first example was based on, again, data, and it was basically a bunch of data where students said how many hours they spent per week watching television. So again, I'll grab this data from my spreadsheet that I shared with you recently, and that's the number of hours that I think 15 students were busy watching TV during the week. I'll copy that, and maybe it makes sense. I don't want to call this the same set S because Desmos will have a problem with labeling two different data sets with the same letter. So I'm pasting now those hours for the total time spent watching TV. That's why I use set T. So I don't know the standard deviation of the population as normally is the case. I'm going to click the plus button, click the inference button, and click the t-test. And again, just like we saw before, instead of clicking stats, I don't have a sample. I do, but the sample is just data-based. So I'll click data, and in here I just refer to that list of data that I labeled T with capital T. It will create the confidence interval once you click confidence interval. We were supposed to do this for a 95% confidence interval, and you will see that the values are a little bit off from what I did on the worksheet, but my values on the worksheet were rounded to only tenths of an hour for the total hours. And so my example in the worksheet had 3.05 to 9.15, and using more accurate values from the data for the mean and the standard deviation would have a more accurate. This confidence interval is actually more accurate than what I had on my worksheet key. The next example was based on hypnotherapy patients and how many hours they slept per night. So there were 12 such patients, and their average number of hours slept per night was 8.98. I'm going to click inference button, and we do not know sigma here, so I'll do a t-test. This will be based on summary statistics. The size of the sample was 12. Of course, on all these t distributions, they will know how to subtract 1 from the sample size to get the degrees of freedom to find the proper critical values for the t, and the t critical values for the error formula to construct the confidence interval. The average was 8.98 hours of sleep with a standard deviation of 1.29. So you click create test. Again, select the confidence interval. This was supposed to be a 99% confidence interval, so I'll change that to 0.99. And these values, 7.823 and 10.14, are almost spot on to the answers you'll find in the worksheet. Last example is a follow-up on problem just like the birth weights problem. So I'll add the inference button here. Click on the inference button, a t-test. This is based on summary statistics. Again, we're assuming that sigma is known and the population standard deviation is 2.9 hectograms for the weight of a baby girl. This size of the sample was a little bigger. We had 22 baby births that were recorded, and the average was also a little bit higher. I think it was 31.1. The last one was 30.9. So we'll create the test, and oh, you know what? Sigma's known, so I shouldn't have created a t-test. That's an easy mistake to make. Click on the plus button, inference, and click z-test because apparently sigma is known. So we go to stats. The size of the sample was 22, and the mean was 31.1. Before, the header on this just said standard deviation referring to the sample, but it's sigma that we know, which is the population standard deviation of 2.9. So when we create this confidence interval, you should see that these numbers are almost spot on to the 29.9 and 32.3 hectograms that are noted on the answer key. I hope this is helpful for you to learn how to use Desmos to construct confidence intervals for the population mean.